In this video, I'm going to answer some questions that we've been receiving when it comes to why do we choose or why do we prefer Tibetan-style hand-hammered bowls in comparison to crystal bowls. And my answer has a lot to do with the physics of sound when it comes to sound healing. So more specifically, what that means for us is this understanding of the energy that's put out by bowls like this. So when you have sound healing itself, it's a form of energy that's considered vibrational or mechanical energy, which really means the pushing of air molecules in this case, because you're singing a singing bowl, or you're vibrating a singing bowl out into the air away from your client, or maybe you're doing a sound bath or something like that. So you have to consider the form of energy that sound uses, which is mechanical energy. That means air molecules, or if you're using it in water or something like that, then it's water molecules. And what that really means is there's something here in the singing bowl itself that's pushing air molecules and making that vibration hit the other air molecules as it propagates out in a sound wave, and then it reaches the client's body in a very specific manner. And that's one of the first things that I want to talk about, is considering how sound actually affects the human body. We have to consider that when we're talking about sound healing, because that's one of those things that tends to get overlooked or maybe misunderstood in the sound healing community, is what actually happens to the body when sometimes we think that mechanical vibrations is a part of our energy field, where we're considering electromagnetic radiation or electromagnetic energy, and that there's this interaction with vibrational energy or mechanical energy. We have to consider that those are two different forms of energy, and that when you have air molecules passing through electromagnetic fields that are crossing each other, that there's not an interaction between the two when they transmit out and propagate out. Electromagnetic energy actually passes through any sound energy that's coming the other way. So that also means the consideration for when sound strikes your body, or when sound waves reach your body, is still physical sound vibration. And so let's consider the source itself, the source of the sound when it comes to singing bowls, specifically this singing bowl, which is a hand-hammered Tibetan-style bowl. So one of the things that happens when we have a singing bowl is we're looking at certain physics of the bowl itself. Singing bowls have actually been tested and researched quite a bit, especially when it comes to certain engineering physics. We know a lot about the physics of certain engineering things. For example, when they test these singing bowls for how it actually works and how the vibrations are created and sent out into the air, engineers actually test these based off of two main criteria that's well studied. And that is, instead of this just being a bowl, they consider the dynamics and physics of this being a pipe. Lots of vibration research and studying on vibration of pipes that move gas and fluids. You want to make sure that those tubes, those pipes, don't vibrate in a certain way that'll actually crack fittings and things like that. So they study the dynamics of cylinders, which this is technically a cylinder at this point right here. It's actually a closed-ended cylinder. Then there's the dynamics also dealing with the same research and studying you would do on pipes, which would be the ring dynamics. So there's two dynamics at play here. There's the cylinder itself here, and then there's the ring, the outer edge of that singing bowl. And it's really with this ring dynamic that most of the studies of singing bowls have been done. And what that really means is that when you start singing a bowl, the vibration that gets created from this bowl happens in this way. And I'm also talking about specifically the singing action of a bowl. When you start to move this around the edge of the bowl, it is really technically the outer edge, the ring, that starts to flex when you start to rub this singing stick around the edge. What starts to happen is you get these flexings, this flexing of the bowl. The ring starts to flex inwards and outwards. Really, we usually think of a singing bowl as having one main frequency, and that's really the loudest frequency of anywhere from 8 to 10 frequencies that are being vibrated off the bowl. So where are those frequencies coming from? So when you start to sing this bowl, it starts out with two sides of the bowl, or two edges of the bowl, starts to bend inward and outwards. And then the longer you do this, the longer you sing it, this dynamic, this ring physics dynamic, starts to make another pair right here flex inwards and outwards. Now you have two separate pairs of frequencies. And then that continues to happen over time, where you have now 4, then 6, then 8. And once you have 8, if you've ever sung a bowl before, you know that at some point it feels like you've reached the maximum sound quality of a singing bowl. And it really means that all 8 of those pairs are now flexing inwards and outwards. Then there's this wave of flexing that ring. Because you're moving this in a circular pattern, not only are those 8 flexing actions happening, but then there's also this wave of flexing all the way around the ring. So if you've ever sung a bowl and then you get to a certain point and all of a sudden your singing stick feels like it's chattering or bouncing or stuttering around the bowl, it's because that wave that's going around the ring has now caught up to your singing stick, and it's basically buffering the singing stick. And that would be a good reason to slow down your circular motion around the rim of the bowl. And really it is the outer ring right here is the part that is the most efficient singing action at the right angle, at the right speed, at the right friction around this ring. So the reason I bring up those physics is to answer the question, why do I feel that a metal bowl is better is more preferred in my opinion than the crystal bowls? It has a lot to do with the way that the metal will flex. You also have to consider what is the use of the bowl. Are we using it near the person's body? Are we moving it away from the body? Are we doing a sound bath? Are we placing it on the person's body? Are we doing it next to the body? Are we engaging a very specific sense? We have to consider our 5 senses as well. So with this bowl being a source of vibration, I just mentioned that there's anywhere from 8 to 15 different sounds that are coming off of this bowl, and those sounds are melding together. You have the intervals between the two, or between 3 or 4 sets of flexing frequencies going on here, oscillations. And those are really making up the entire broadband sound coming off this bowl. And another thing that happens with these bowls is this is more of a megaphone effect, that all of the vibrations that are bouncing back and forth here actually has the ability to transmit out, very much like the whole of a guitar or other instruments that have standing waves inside of an enclosed compartment with these flexions bouncing back and forth to each other. Next thing you know, it gets louder and louder because they're constructive interference with these waves coming back and forth. You need some way to get it from here out into the environment. So when you have an enclosed environment like this, to be able to transmit it out, now it actually goes out into the air with combined frequencies. And that's where you find the wah, 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 wah effect, because you're not just seeing one frequency, you're not experiencing one frequency, you're experiencing several of them that work together. So those have to be considered. For this point, it really has to do with, you have a source, and a mechanical vibration, it travels out and propagates outwards, and then you have a receiver. And the client, the person that's receiving sound healing from this bowl, is the receiver. So what do we have in our physical body, or what physical components in our body receives a vibration like this to where we can process it? It's not going to be our vision. Out of our five senses, it's not going to be our vision, because a lot of times, we can't see a sound vibration. We can't see mechanical vibration, or we're not tuned to see mechanical vibration unless it's a wave in water or something like that. Taste and smell, probably not something that you would consider as being a receiver part of our physical body. Then we're left with touch, and we're left with hearing. So those two senses are the main thing that really benefits from the singing bowls. And you might also be thinking, well, what about the cells of our body, and having our cells change themselves by being entrained to the sounds that are coming into our body? First thing to consider in cell resonant theory is that there's multiple vibrations coming from the singing bowl. So by the time the vibrations actually reach the cells of our body, how does that cell know exactly which frequency out of the 8 to 15 to actually try to entrain itself with? And not all cells in our body are meant to entrain to certain frequencies and stay that way permanently. You have to consider that some cells are designed to be clock cells. They're supposed to oscillate at a specific frequency to keep timing with the rest of our body. So we have those things to consider. Then, what other parts of our body has to do with touch sensitivity? They're just underneath our skin. There's a lot of different cells that are looking for an understanding of our outside environment. That's things pressing against us. We have sensors in our skin specifically designed to sense pressure, for heat, if temperature itself. Then there's burn sensors or heat sensors that show that maybe I'm holding my hand on something totally hot and it's going to damage my skin. Then I have, reflex, and I have burn sensors. Then you have puncture. So when I get punctured, that would also send reports to my brain to know that my body has been punctured or cut or something like that. We have very specific sensors for vibration detection, and some of those sensors are very specific to the palms of the hand and to the soles of our feet. Some of those sensors are very specific to non-hairy skin, and then the hairs of our body itself is designed to sense our external environment as well. A lot of that has to do with airflow across our arms or across our hair. Those are sensors as well. So that's one type of sensor, and that has to be considered when we have vibration going out into the air and our body is receiving external communication, external something. It's external vibration that is hitting our skin. Then we have our auditory system. Our auditory system has to be considered separately from this sensor system. Eventually they're going to combine together to where your brain maps out what's happening with the external environment. But when it comes to the actual moment that the vibration is reaching these sensors, you have to consider how that happens. So auditory vibrations hitting your ears processes in a very specific way, and then vibrations that are hitting our skin processes in a completely different way, and you have to consider those. So when you're using sound healing, and more specifically singing bowls in this case, you have to consider what's happening with the vibration once it actually reaches the person's body. I want to talk more specifically right now just about the sensors themselves in your skin. Once the vibration finally reaches your skin and then hits the skin, remember we're talking about molecules of air. Usually the biggest air molecules or the most air molecules is oxygen and nitrogen, and they will collide with each other. They basically sit there and oscillate just like this, and then when you have a singing bowl or a source, it's pushing hard against the air molecules, kind of like in a wave machine. If you ever seen a wave machine that actually pushes the water and then you have a wave coming out, that's what happens with something like this. Remember, there's flexing back and forth that creates the pushing against the air molecules. Tuning forks, these tines are swinging back and forth, which pushes the air molecules outwards and propagates the vibration in waves outwards. So what happens when I'm singing this bowl? I have a certain amount of strength of pushing the air molecules. Now, it is the volume that has, in the loudness from the singing bowl, that has very much to do with how far the vibration is going to get away from this source. And we call that decibel level. Decibel level right here at the source. And so when we usually think of frequencies, we usually see this waveform that people are drawing. That has two components to sound. There is the up and down part, the wave peak and the troughs. That's volume. The higher that peak is on both sides of that line, the louder that volume is. And it really equates to a comparison would be if somebody walked up to you and just slightly tapped you, that would be something like this. Or they came up to you and shoved you. That's a larger peak and valley. That's volume, that's loudness. That would equate to how much, if you struck or chimed this bowl, now you're actually flexing harder and faster, and there's a louder sound to it than me striking it softer. Now your loudness is less, your peaks and valleys are less. That's going to determine how far away the sound goes before it gets less and less and less. Every time the molecules strike each other, they're striking with less force between the two. Eventually you're going to lose decibels in sound between the source and the receiver. So if this singing bowl, so basically what I'm saying is distance between the source and the receiver really matters in this case, and the loudness really matters in this case, more than the other part, which is, you have the frequency that's drawn out this way. Well, this part of that XY plot is timing. That's usually what we consider frequency, but sound has two components. Volume is up and down, and timing is this way. We usually think of frequency as cycles per second. This is 136.1 hertz. That's 136.1 times per second. One of these times does a full cycle of movement. The same can be said for the singing bowls. So we're more considering now the volume and how far away it is and how far it has to travel through the air. I spent 22 years in the Navy studying sound. It was underwater acoustics, and sound works the same way in the air itself. And we studied things like this. We studied how equipment in submarines and ships vibrate and rub and make noise, and that was my focus for over 20 years. And one of the things that we have to consider, and one of the things that I often consider with sound healing, is what's the volume here, the loudness as it travels away. That's what I start with. Then as it comes outwards and travels out into the room, we're talking it's traveling through air now. It bounces off of walls, it scatters, it finally makes itself to me. And sometimes some sound is making it directly to me, to my face, to my skin, and then some of that sound has a direct route to my ears. Remember, two different processing systems here that you have to consider. The irony is that in sound baths, where we put air or vibration, lots of vibration into the room, that you're being bathed in frequency and vibration. But the capability of actually compressing the sensors that are looking for vibration, they're a very specific type of sensors. One has all these laminated layers to it, and when it gets compressed, it understands even very minor disturbances to the skin. So once that vibration actually hits the skin and your body can detect it, then that becomes a rhythm, and your brain understands rhythms, and that's where we entrain our brain and our peripheral sensory system. So how far away this singing bowl is really going to determine whether there's still enough physical strength against the air molecules to transfer that last molecule just before it hits the surface of my skin. It still has to have enough force left in it to compress my skin and also compress the sensors, the vibration-based sensors in my skin, to say, yes, I detect vibration. It's a communication system, remember that. If there's nothing left on the other end when vibrations hit our body or the sensors of our body can't detect it and can't process it as information. When I was in sonar, that was one of the big things that we had to make sure that when we transmitted sound out, that we had to do it in a certain way that the receiver still could not only pick it up, but it could also pick up enough and determine that it was different from the background noise and actually do something with the information when it was received. There still needed to be enough force left for the sensors to say, oh, I just heard something over there, and I identify it and I need to process it. If there's not enough left, the sensors don't pick it up, or they don't pick it up enough to be able to identify it from the background noise as a distinct source, and there's not enough left to process the information. Remember, when it hits my sensors here, I still have to have enough for that sensor to send its own information through a pulse. Well, really, it's going from here, it's going to go to my spine, and then it's going to be transferred to an interneuron, and then it's going to be transferred to another one, and it's finally going to make it up to my brain. There still has to be enough for the individual sensors in my skin to say, oh, okay, there's a vibration. I feel a vibration, and I feel that it's happening over and over again. Frequency, oscillations. And then with our ears too, there has to be enough to get in there and be able to push that membrane in there to transfer those vibrations to your cochlea. And then inside the cochlea, the little hairs try to now identify the 8 to 15 frequencies in there. Okay, so I hear that one, and then this hair starts to vibrate. And okay, now I hear that one too, so there's these frequencies. All right, now I'll send that to the brain and I'll figure out where are these sounds coming from. So when it comes to having singing bowls out into the air and it reaches me, distance is a big thing. If you're singing it near the head or near the body and you're singing it, it's long-term vibration, that's a big thing. By the time it reaches, it doesn't have very much to go to compress my vibration sensors in my body. If you have it way out here in a part of the room as a sound bath, your body's still processing it. But I can tell you that there's only a maximum amount of decibel level, loudness that comes out of here. And by the time it actually bounces off the walls and it makes it to me that may be 5 feet away from your sound source, it may not have enough left to change my sensors and to activate the sensors in my skin to tell my brain there's a repeating source, a vibrating source out there, and start paying attention to the rhythm and change something in my body based off those rhythms. Your ears are more likely going to be the main sensor receiving a sound bath vibrations, because it's more designed to receive information through the physical outline, the pinna of your earlobe, and then it actually has ways of bouncing vibrations in your earlobe to make it go into the ear canal. Once it's in the ear canal, now you're in a tube, which changes the way that vibrations travel. It actually enhances vibration travel once it's inside the earlobe. Then we have auditory processing that we would consider after that point when it comes to sound. So I say all these things to come back to the original question about why do we prefer metal type bowls to crystal bowls. It has very much to do with the physics of metal. First of all, the metal that was created, or the metal that was used to create these bowls, I don't really get caught around the magic of the bowls and the Tibetan style and the stories that are told, because these are probably just brass type bowls. They were in fact made overseas, and they probably weren't made with the same 8 metals that you usually consider or read on the internet as far as these bowls being created in a very specific way. But the metal itself is hand hammered, so it takes the molecules in that metal and compresses them together, which means there's much more capability of these singing bowls. If you get the right singing bowl, you're going to know what I'm talking about. When you start to sing them, the loudness now becomes much better. The way that the flexing of the ring of the bowl and the way that it vibrates the bowl itself and sends vibration out has a much more strength and much more flexibility than what I find that crystal bowls are. So when you have a crystal bowl, which we don't carry crystal bowls, nor do we use them, the crystalline structure in the bowl is designed to be stable. You may have a much different sound for crystal bowls. It's sending less different frequencies out into the air. And you may think that if you sing a crystal bowl that it's going to be louder than the bowl right next to it, and that might be true in some cases. What I find that when I've had crystal bowls next to metal hand hammered bowls, that especially once you lift the singing stick off of a crystal bowl, it tends to dampen out very quickly, because the continuous vibration of the crystal itself tends to dampen out and die out quickly once you remove your own friction against the edge of the bowl. And with these bowls, they're very well suited for singing, starting it up, getting it up to its best singing vibration, and then once you let off of them, they tend to sing for a very long time if it's a good quality hand hammered bowl. And what they even do on some of these bowls is this one. So really, they don't know what frequencies these bowls are going to be by the time they get done molding them, hand hammering, and they finally get done shaping them and they cool down. And really at that point, it's kind of by pure luck that they get a specific frequency. But then you can fold, like this bowl right here has a really thick ring to it, a really thick edge to it. And they can fold those edges over and start to tune these bowls in this manner, or maybe heat them back up and hand hammer them a little bit to decrease or increase the outer edge diameter. It really is more the weight of the bowl, the thickness of the ring around it, the materials of the bowl itself. Those all come into play here. And when you make this ring thicker, you can, in this one, there's actually a lip around it. It looks like they've been hand hammered and folded under, and then you have a nice thick bowl. These type of bowls tend to lower the range of the overall frequency from the ring. So they're able to drop it down by maybe an octave just by changing the thickness of the ring around here. And then you have really, really old bowls, or at least we were told this was an old bowl. The weight of this bowl is about half the weight of this bowl here. Different materials, maybe it was made in a different way, but it's extremely light. So there are definitely completely different materials that change the way that this bowl here vibrates compared to this one and a really heavy, larger one like this. So, so we prefer bowls like this. We prefer bowls that are going to be able to have multiple frequencies. In the case of a sound bath, you want things bouncing off the walls. You want, as far as we're concerned, the whole purpose, and the main purpose of a sound bath is not necessarily that I'm soaking up frequencies into my skin. I'm probably not doing that, and I don't suspect that that's the main thing that's happening. What I believe the main thing that's happening is most of that is making it through to the auditory system, because in a sound bath, where most people do nothing but lay there, sit there, and focus, and they can focus on one specific thing at a time while there is a very repetitive, rhythmic sound coming into their ears. Our brains use the rhythmicity of music and repetitive rhythms to start to reset certain things in their brain, certain clocks in their brain where, or neurons that are clock-based neurons need a rhythm. Your brain needs certain rhythms and expectations that the next thing that's going to come into my ear is going to be on the same beat. That's why music therapy works very well. It's because our predictive coding, our ability for our brain to remember and see our environment from external sensors, your brain has to anticipate those things. So you have what's called predictive coding. Your brain will create what it thinks is a representation of the outside world. And when things don't happen in the same way, the external environment feeds you something and you see something or hear something that doesn't make sense to you, or you're singing a song or hear a song and then it doesn't finish, you get a prediction error and it needs to be updated. And the prediction error is the difference between what your brain thinks is supposed to happen and what you actually experienced that happened. When the prediction coding is too much, we call that trauma. So music therapy and rhythms themselves, when they come into the auditory processing system, tells your brain, here is the rhythm you should be focusing on. And this is more of a focusing type of thing. Very specific to music therapy is the fact that music is written in a certain way where there's anticipation for what's going to happen next. A good song or a good piece of music has expectations written into it, where you flow in a certain way, and the emotions that get brought up and the feelings that get brought up from certain types of music, a lot of that has to do with the way that whether you're anticipating the next thing or the song shifts into something completely different, or the rhythms themselves are creating a different feeling for you. So bowls like this have a very good wah, 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 wah effect. And those wah-wahs are enhancing of frequencies. If you've ever understood the concept of constructive interference, you have two frequencies close to each other. And when their timing is close to each other, they can actually increase the volume. So you got two sources here. Each of these sources are close in frequency. And when they're combined together, if they're close enough, they can increase the volume of each other to a certain point. And the intervals in these different pairs are actually creating these wah-wah sort of points, and they're loud. They're the stuff that's really going to get to your ears before anything else. And that's a good rhythm. Lower frequency rhythms tend to be much better for our audio processing system. So it's not necessarily about the frequency itself. Again, it's about the loudness. And crystal bowls might be able to create that wah-wah effect. But again, we're talking about metal here. We're talking about metal has a really good ability to flex more than what I believe that crystal can flex. In a thick crystal bowl, there's not a lot of room for movement and flexing. You are vibrating the bowl, and the crystal bowl is sending frequencies out into the room. But I don't believe that it's the same force and loudness that the flexing of a hand-hammered metal bowl is. And it really has a lot to do with just physics of the bowl itself.